And yes.
This is a long-throated flume that is calibrated by the process wind flume that is maintained by the Bureau of Reclamation in Denver. And what I've installed here is a sill and a ramp. And some people call it a ramp flume, some call it a, well, otherwise, Replogle flume, whatever. But anyway, what we're doing is we're measuring the head of water through the little holes in the static pressure tube that's being siphoned into this cup. And this is the head we need upstream. That's where a wall gauge would be ordinarily. And we're bringing, and rather than using surveying instruments, I'm just bringing that siphon level into this cup, which is above the, what we call the sweet spot. It's about 1/4 of the way up the flume and in the middle. So it doesn't matter if it's tilted a little bit or a little, any direction, it's fairly tolerant. So I now have measured that distance from the floor into the cup. In this case, I happen to have access to a point gauge, so I use it. Otherwise, you can use a sharpened piece of dowel stick and a ruler, and you can get within a millimeter. And that's what we use when we don't have access to a nice point gauge. Anyway, and the cup can be made. I've made cups out of Coke bottles, so the cups can be made. Don't have to be this precision here. So that's about the whole story. Is
So how do you then take the measurement and turn it into a CFS measurement?
Well, I have to take this depth that the water is above the sill here. I have to take these two. The depth up here is siphoned to here, and that depth then is I've entered in the table that is computed by the wind flume, and that's where I get that number. Converts it to CFS.
All right. Can you show us what is running right now? What CFS is running?
Let me see. When I subtract the 0 away, I'm ending up with a net of 0.7 to 3 feet of depth. And when I put that into the computer table over here, .733 gives me 10.12.
Can you point to that one on the screen?
10.12.
Thank you so much.
CFS. And of course
thank you, Dr. Replogle.